Okay, so what we're going to do now is we're going to have a look at example 3 from the extended problems with Venn diagrams page. It's the second last page. As always, it's up to you whether you take the notes or not at this stage, but it's worth paying attention to, I think. What I said to you last lesson was that it's probably, for a lot of Venn diagrams, you probably don't need an algebraic approach to it. As long as you just start drawing the diagram, filling in the information you know, and then calculating the bits of information you don't know, you're pretty much right to go. But sometimes it is impossible to do that. You need some algebra in there in order to make sense of it all. And example 3 there from the sheet set is one of those situations. So what we do, I'm going to approach this problem like I would as if I'd never seen the problem before, so you get a sense of how to go about it. And as I said to you last lesson, one of the most valuable things you can do is read the question and reread the question and reread the question. Don't be afraid to continue to go back to the question and read through it. So we'll read through it first once, and then we'll start doing some construction at the end of that. So example 3, when 46 students were asked what pets they kept, I'll say that again. When 46 students were asked what pets they kept, their answers were a little surprising. 20 kept lions, 15 elephants, and 25 snakes. 8 kept lions and elephants, 10 lions and snakes, and 6 elephants and snakes. 5 had no pets. How many students kept all 3 types of pets? Okay, so that's my first read through. I make sure that I understand what I'm looking at here. All right, so what comes to mind straight away? Let's imagine we didn't even know it was a Venn diagram problem, even though the title's right above it. We would be saying to ourselves, okay, well, I need to make sense of these groups of students, and it looks like we have groups. So as soon as you identified that it would make sense to organize these students in terms of groups, quite often a Venn diagram is the way to go. So in slide 1 here, I'm going to draw a Venn diagram. And then reading through it again really briefly, I'm now identifying what the groups are. So the major group, the universal set, is the 46 students. That's okay. So, and then I've got, let me see, lions, elephants, and snakes as the 3 different pet groups. So I'll need 3 circles. So what I do is I start with that. I draw my 3 circles as well as I can. I'm not that good at drawing circles. And I make sure that all of my groups intersect, which means cross over each other. Now, this is a Venn diagram, so I'm going to immediately put it into a box to represent the universal set, the whole set. And I'm going to, outside it, write down the number that the universal set adds up to, which is 46, because there are 46 students. Okay, I'm going to label my circles. So I'm going to make this one lions. I'm going to make this one elephants, and I'm going to make this one snakes here. Or to be more precise, this group here represents the number of students who own a lion. This group here represents the number of students who own an elephant. And this group here represents the number of students who own a snake. Okay, also, it's probably pretty important to just remind ourselves about what all these intersections mean. So now, I'm just going to colour it in actually, and then I'll undo it bit by bit. So this bit I've shaded in here, don't worry about that little line in the middle. That bit I've shaded in represents all those students who own a lion or an elephant. Sorry, and an elephant, beg your pardon, not or, and. Okay? That's pretty important. This bit here are students who own a lion, because it belongs in this group, and an elephant, because it belongs in this group, but they definitely don't own a snake. Okay, because there's none of that group mentioned. Okay, so we could go around the whole lot for that. But importantly, I guess here, the bit I've highlighted here, that would represent students who own a lion and an elephant and a snake. So it's the intersection of all three circles. We good so far? Questions? This is important because you don't get this bit. The rest of it's going to be like magic. Alrighty. I'll just undo that. The other thing I wanted to point out was what? Something. Oh, yeah. And just to remind you then that the numbers I get in these 4 sections now for a 3-circle Venn diagram, these are the numbers that when added up would give me how many students own a lion. This would be lions only. This would be lions and elephants and no snakes. This would be lions and elephants and snakes, and this would be lions and snakes and no elephant. So each of those has a very specific role to play. But when added together, it would give me the number of lions. Okay, well, the number of students that own a lion, to be precise. So what we do then is we'll go through it again, and this time all I'm going to do is I'm going to fill in any number that I can fill in just from reading it. So no calculations, just what are we told. So when 46 students were asked, yep, what pets they kept, yep. Okay, it says 20 kept lions. Okay, I can't write that number 20 in yet because 20 has to be represented in this whole section. Okay, each of these 4 bits need to add up to 20, so I can't write out 20 yet. So moving on, 15 elephants, same thing, I can't write 15 yet, and 25 snakes. I can't fill in the 25 students who fill in snakes yet for the same reason, because it would be all of those 4 sections added together to get me 25. 8 kept lions and elephants. Okay, this is a bit more, a bit better. So lions and elephants, this would be this section here that I highlighted before. But it's still divided into 2 regions. So I can't even write 8 down because I've got 2, it's got the 8 has to be the sum of these 2 numbers, which we still don't have yet. Does that make sense why I can't write it down yet? All right, keep moving then. 10 lions and snakes. Same thing. Like here are lions and snakes, but I can't split I don't know how to split my 10 yet. So I've got to leave that. Let me see, 6 elephants and snakes. I can't split the 6 into those 2 sections yet. So I'm stuffed there as well. So we've nearly got to the end and I haven't written anything down. But that rereading is really important because it keeps on reinforcing what I know and don't know. It says 5 had no pets. Finally, something I can write down. Because in the in the box over here, I can now write the number 5 down. Because that does not belong to any of the groups that I've made. All right, yay. We haven't got our answer yet, but is that okay so far? That's the next pass through of the question. Now, we need to do something with the rest of the information. So let's start looking at what we need to find out eventually. It says how many students kept all 3 types of pets. Now, what I showed you before, and I hope you remember, is this section here is the section that deals with all 3 pets. So what I'm going to do is I'm going to fill in the missing section with an X to start with. Okay, that represents what I don't know. Now, the thing is, if I can fill in the rest of this Venn diagram with nothing but X's, then I will be able to create an equation which I can solve, because an equation with one unknown is solvable, usually. Is that okay? So what I'm going to do now is I'm going to go through the information again, but this time I'm looking to see if I can fill out anything else in terms of X. So when you hear the phrase in terms of, and then a variable, in this case X, it means write an expression which has an X in it and no other variables. Okay, so let's have a look. 20 kept lions. All right, I'm still stuck here because I've still got 3 unknowns here. There's not much I can do here. Similarly with the 15 elephants and 25 snakes, I still don't have enough information down yet. But then the next bit of information I've got is that 8 kept lions and elephants. Now I know that this section here is lions and elephants, and I know that this total here has to be 8. So in other words, X plus whatever this is has to equal 8. Can anyone now sort of maybe intuitively jump to putting in an expression in here which would be in terms of X? If this is X, then the value in here would be, Simon? Well done. Perfect. Does that make sense? Right. So if I just did a sideways step, I'm just using the whiteboard on the side now. I'm just saying that for the video so that people know I'm not going crazy. If I said that that value up there was instead y, I would say that x plus y is equal to 8. So if I took x away from both sides, I would say y is equal to 8 take away x. So that's where the 8 minus x comes from. Or to put it just in a straight numerical way, let's just say, I know the answer's in the example already, but don't worry about that. Let's just say that x was 3, then we'd know that this number would have to be 5, right? How would we get 5? Well, I'd take 3 away from 8 to get 5. Okay? So they kind of complement each other. Alrighty, so that's 8 minus x. So using the same sort of logic, it says there are 10 students who keep lions and snakes. So raise your hand if you think you can write in the expression that goes for lions and snakes. There you go. So A is going to write in what she thinks. It's okay if you get it wrong, don't worry. Oh, is she right? Is she right? Yes, she is. She's right. Well done. So that's 10 minus x that goes in there. And then the next fact is, what was it, 15? I don't have it in front of me now. Oh, 6. 6 elephants and snakes. Who'd like to write the expression in the right spot there? Good. Nice work. Okay. 6 take away x in that last spot there. This is really good. We now have a whole bunch of more sections filled in terms of x. Now, the next thing to do is to fill in the 3 major areas here. So this is lions only, elephants only, and snakes only. Now, I'm going to do one for you, and then I'm going to leave it for you to try and do the rest of them. So let's have a look at lions only for a start. So we know that 20 kept lions, okay? So that means that this plus this plus this plus this must equal 20. Is that okay so far? Now, this is the thing I hope doesn't blow your mind too much. To put it another way, this value in here must be 20, take away this, take away this, take away this. Do you know what I mean? So if that was like 5, 2, and 1, this would be 20, take away 5, take away 2, take away 1. Okay, that's all right. Let's do that. What makes it tricky is that there are variables instead, but it's okay. So lions only would be 20, take away. Now, what I'm going to do is I'm just going to work around clockwise so I don't lose track of my takeaways here. And whenever there's an expression, I'm going to put it in brackets. Whenever you're taking away an expression, put it in brackets to start with, otherwise you'll get confused. So 20, take away, sorry, wherever you're writing it down, Jamie, is fine. 20, take away 8 minus x. Okay, so that's the lions and elephants, but no snakes. Take away x, that's the lions, elephants, and snakes. Take away 10 minus x. Good so far? Now I'm going to simplify, and I want you to make sure you're listening watching very carefully for this. When you've got a takeaway, you need to get rid of those brackets, otherwise we can't simplify. So when we're taking away an expression, effectively we just reverse the signs of everything inside the bracket. So instead of 8 minus x, I'm going to have minus 8 plus x. Okay, so to put it another way, minus positive x is minus x, minus minus x is plus x. Taking away a minus is the same as adding. Okay, minus x, minus 10, plus x. Okay, just reversing those signs as I'm going along. Some people will want to skip that step. I'm telling you now that even after 20 odd years of teaching, I would still do that step because it's too easy to get your negatives mixed up by mistake. So I would always do that step. Now, what I do when I have an expression which is a bit long is I then go along and put ticks above the numbers that I'm going to sort of collect together. So we're collecting like terms. 20 take away 8 is 12. Take away 10 is 2. So I'm left with 2. And then I've got x minus x is 0. 0 plus x is x. So I've got 2 plus x. So that gives me my expression that I can write in here. That's all right, I think. Now that I've done that, can you please spend the next, I'll just give you maybe 2 minutes or so to see whether you can fill in the elephant and snake blank bits, and then we'll come back and discuss it. Okay, so if you did it right, we've got elephants only would be 15, take 6 minus x, take 8 minus x, which would be 15, take away 6 plus x, take away x, take away 8 plus x. 15 minus 6 is 9, 9 minus 8 is 1, plus x minus x is 0, plus x is plus x. And then for snakes only, just stop me if I'm going too fast. For snakes only, we would have, let's see, 25 snakes. And then we would go minus 10 minus x minus x minus 6 minus x, which equals 25 take away 10 plus x, take away x, take away 6 plus x. That would give us 25 minus 10 is 15, 15 minus 6 is 9, and plus x minus x is 0, plus x is plus x. I hope you can see that putting those little ticks in front of, on top of the numbers doesn't stop people from being able to read it, but helps you keep check of what you've used and not used. Okay, so that means we can now fill in with 1 plus x here and 9 plus x here. Yay, we now have a completely filled in Venn diagram, not with numbers, but at least they've only got one unknown, which is x. So if we can work out what x is, we can actually write out the entire Venn diagram with numbers instead of variables. So the last part of the piece of the puzzle then is to go back and put it all together. And the only fact we haven't really used yet is that all of those different parts of the Venn diagram have to add up to 46. So let's use that fact to finish it off. So I'm going to go around my Venn diagram and just try and add them all up and set it equal to 46 and see what happens. Now, what I'm going to do, I'm just trying to make sure I'm being methodical about it. So I'm just going to go across ways and adding them up this way so I collect everything. So I've got therefore 2 plus x. Now that I'm adding stuff up, I don't have to worry about brackets because when you add stuff up, it doesn't really affect it whether there are brackets there or not. 2 plus x plus 8 minus x plus 1 plus x plus 10 minus x plus 6 minus x plus 9 plus x. And I know that whole thing has to equal 46. It's long, but it's not that complicated. So I'm just going to go and tick the numbers first and add them up. So 2 plus 8 is 10, plus 1 is 11, plus 10 is 21, plus 6 is 27, plus 9 is 33. And then x minus x is 0, plus x is x, minus x is 0, plus x is x, minus x is 0, plus x is equal to x. Okay, so we're just left with a single x. Did I add them up wrong? I got distracted in the middle by someone muttering along, so I missed it. Thank you. Sophie just reminded me that I hadn't put in the 5 here that didn't have pets at all. Thank you. So I'm going to put that in a different color so we remember. And did I add up the other numbers wrong as well? Okay, so that +5 comes from here, the 5 students that had no pets whatsoever. Genuinely, it's that little muttery talking that you think doesn't affect anyone else really bugs me. It puts me off my game and makes me probably say things like 2 + 8 = 11. So don't do it, please, just out of respect. So again, I'll just add up those numbers again because I'm a doofus. So 2 plus 8 is 10, plus 1 is 11, plus 10 is 21, plus 6 is 27, plus 9 is 35, plus 5 is 40. Have I added it wrong again, have I?
36 and then...
Okay, thanks. Fair enough. So what was it? 39, was it?
The full answer is
41. Okay, I don't know what I did there. I can't blame noise this time. It was just me being a doofus. Okay, so it was 41 plus 5 plus x is equal to... Now, here we can solve the equation, but we don't really need to, do we really? At 41 plus x equals 46, we can probably work out what the missing bit is there. X is equal to 5. Sorry about my addition mistakes there. So x is equal to 5. And importantly, I think for problem solving in general, we right? In general, is that we go back and answer the question. So it says, how many students kept all 3 types of pets? So we've worked out x, and x is that middle number. And so we can just say, i.e., 5 students kept, this is just good communication, kept all 3 types of pets. And then we're done. Now, what you can see in the example that I gave, this written out example here, is I then filled in the entire diagram with the actual numbers. Now that we know what x is, we can go and backfill. So we can say that that must be 7, that must be 3, that must be 6, and so on. I'm not going to bother doing that because it's probably just a little bit of a waste of time at this stage. Plus, in terms of the question itself, that's all we need to do. But if we did fill in the entire Venn diagram, we can then say things like, okay, in that group of 46 students, what's the chances if I pick someone at random, what's the chances of me picking someone who has only an elephant as their type of pet? Or what's the probability, given that they own an elephant, that they also have a snake? We can answer all those kinds of questions if we fill out our Venn diagram. Any questions? Okay, so this will be on Google Classroom for you to access in about 5 minutes or so. Other than that, if you want to, we've now got 10 minutes left in this lesson. You can either choose to continue on with exercise 1, or if you feel like that was something that you'd like to get your teeth into, something a bit harder, then get stuck into exercise 2 now. And I'll try and give you a little bit more time next lesson as well.